Well, thank you so much, everybody. It's a pleasure to be here. It's my first time ever at the European Lisp Conference or any European Lisp Conference. So I'm really happy to be here and share my thoughts. I'll come back to the slide in a minute. Just wanted to give you a little bit of a background of my background in Lisp. So it goes all the way back to 1991 when I first came to the United States to study with Dan Friedman. He was my PhD advisor. Dan Friedman, some of you may have heard the name, very famously known for the Little Lisper and all of his numerous contributions to Lisp over the years. He recently retired from Indiana University. But it was an honor to study with him, to get my doctorate from him. And from there, I went on to work at Xerox PARC with two other iconic names, Gregor Gonzalez, who you might have heard of. He was the creator of Portable Common Loops, or PCL as it's called. It's the implementation of CLOS that practically was running on almost every Lisp that was out there. And the roots of it are probably still in all the common Lisps that you guys use. So I had the honor of working with him and John Lamping, also famously known for the optimal lambda calculus. With the two of them, I was working on this new paradigm that Didier referred to was called aspect-oriented programming. And all of our early work and, obviously, the research that we were doing came from, Lisp and Scheme and that whole culture. So anyway, that's a little bit about me. Ever since then, I have been using Lisp in various forms. I eventually ended up, from Xerox PARC, I ended up doing a series of startup companies. Currently president of Paper Culture, where I still continue to use Lisp. My favorite flavor is Racket, I will admit. But I have stuck with it for the last 34 years. So anyway, one of the things that got me into artificial intelligence about 12 years ago was a talk that I heard from Peter Lee, who was then at Microsoft. He was the CTO, I think, at the time. And he started talking about how deep learning is starting to become a very important thing in the field. And that's what got me into AI. And I started studying it very deeply. And I realized that the whole pedagogy of AI was completely messed up. The mathematics was too forbidding. Everything about it was so hard. So I decided to write a book with Dan Friedman called The Little Learner. And that came out a couple of years ago. It uses Scheme as the language of instruction and talks about how to develop deep learning from first principles. So it doesn't assume that you know anything more than a little bit of high school math. Okay, so that's how Lisp and AI sort of became somewhat of a passion of mine ever since then. Okay. What does this refer to? How many of you have seen the movies Back to the Future? I hope I see, there you go, quite a few hands. All the young ones haven't raised their hands, but I shall forgive them for that. Back to the Future, story of a person who goes back into 1955 from 1985. And then the whole story is about trying to get him back into 1985. Okay. And then from 1985 goes all the way to 2015, again, 30 years plus. So these are sort of important dates for us. And so I decided the theme of this was going to be Back to the Future and how Lisp was going to, it started in the age of AI. We're now in the age of the next age of AI. And what does Lisp sort of have? What role does it have to play here? Okay. That, of course, is me in a much more muscular form. But, all right. So in order to understand why Lisp was so dominant in the first age of AI, and really one of the reasons why 50, 60, 70 years later, we're still talking about Lisp, is because it was carried with a momentum in the 1960s, 70s, and 80s that led to a lot of innovation and development in the first age of AI. So it's sort of important to understand why Lisp dominated in the first age of AI. And for that, I have a little timeline. I hope you all can see it. It's rooted in logic, right? And logic is sort of this really venerated, one of the oldest disciplines of human philosophy or in human thought, where all the way starting with the Rig Veda and Aristotle and all of those people, they were trying to lay out the rules of thought and how thinking works and how you come to decisions and all of that, which sort of in the 19th century, 17th, 18th, 19th centuries, started to come together in the form of mathematics. So you started to see Boolean logic and predicate logic, and then of course the sort of the modern logicians, Russell, Whitehead, Church, Gödel, Turing, von Neumann. So by the time computers came around, the assumption was that, hey, we know how logic works. We know how humans think. We've got it all down pat, right? That was sort of the going-in assumption. So we can, now sort of take this body of knowledge that we've built over centuries, and we can computerize it. We put it into programs, we make those programs work. If the hardware is good enough, we can figure out the software. That was the sort of spirit in that time. And no one, of course, captures it better than John McCarthy. So this is a quote from him. So I'm not going to read the whole quote out, but I want to talk about how they thought about AI or intelligence in general. The idea was that there's a body of knowledge that you have in your head or wherever, right? And that's called the epistemological part, right? That's the knowledge that you have. And then you do something with that knowledge. You make decisions, you create content, you do whatever you want with that knowledge. And that's called the heuristic part. So all intelligence and all intelligent sort of applications in computer science are based on this philosophy that you build a knowledge graph and you act on it. Okay. So Lisp captures this perfectly. Okay? How, you ask me? First of all, let's look at how we build knowledge graphs in Lisp. Quote, cons, nil. And we're building these lists of symbolic knowledge rules. Right? And you can make them as complicated, as big as you want, with very few constructs, such as these three things. Right? So, great. I can build complex knowledge graphs. And I have a very simple computational framework to actually access this knowledge that I've put into my graph. So you have your character lambda cond, right? Essentially what all you need, but of course Lisp has lots of other goodies like recursion, dynamic typing. It has a REPL, which means you can sort of experiment with your knowledge graph. You can change it, you can modify it, you can update it, you can evolve your algorithms as you go along. You do a lot of things. So, Lisp was just the perfect vehicle for operating in this way of thinking, right? And that's what made it so successful in the early days of AI. And this is a little caveat here. Some of these graphs, the data from 45 years ago is a little hard to get, but I've tried my best to get as much as I could. So some of it is extrapolated. The shape is roughly right. Okay, so Lisp was very successful at capturing this. So when the 80s came around, computing was getting better, the hardware was getting better. the applications started to come together, both from, a lot of this funding was coming from DARPA, but even on the commercial side, there was a lot of activity. People were starting to invest in expert systems, and that's that sort of green line over there. Almost half the market was expert systems. So, so by 1987, the Lisp applications market was about $2.2 billion, roughly, give or take, right? To sort of put that in context in the sort of modern age, it's about $6.5 billion of today's dollars, okay? For reference, back then, Microsoft was doing $1.1 billion, $1.2 billion of MS-DOS business, and IBM PCs were about a $9 billion business. For today's reference, OpenAI, I think in 2024, was doing about $2.5–3 billion. So you can imagine that the Lisp applications market was hugely successful by, even by today's standards. This was back in 1985, 87, right? So the Lisp side of the world was actually leading innovations in sort of numerous ways. First of all, there were real-world applications that people were excited about. They wanted more. They were demanding more of that. There was dedicated hardware. So people said, okay, if you want to run bigger systems, bigger expert systems, make decisions faster, we need to start building dedicated hardware. So you got things like the Lisp machines and hardware designed specifically to run Lisp. And then, obviously, because all the big thinkers were gravitating towards the whole Lisp side of the world, you had high-performance computing coming out of there. So anyone heard of connection machines? There you go. So connection machines were made by a company called Thinking Machines, Inc. Danny Hillis was the founder of those, was that company. And in 1993, 5 out of the top 10 world's fastest supercomputers were coming from Thinking Machines, Inc. Right? So by no means, and they all ran this thing called Star Lisp, which is, again, another sort of great innovation, right? So if you came from the connectionist school of things, you're still dealing with Lisp, right? So, unlike sort of, you talk to a kid today, it's like, I work in Lisp, like, it's an old language, you guys, they sort of look down upon it in some ways. And it was a beacon of invention, a beacon of innovation, a beacon of sort of growth at the time, right? So if you look at sort of, again, in terms of the market itself, about $500 million of hardware being sold at the time, which is, this is serious money, right? In today's money, it's about $3 billion, right? No, $1.5 billion. So, of course, so all my graphs stopped in 1987. Why do they stop at 1987? What was so bad about 1987? Cracks started to appear, okay? Interestingly enough, the cracks actually started to appear in the epistemology side of the world. These knowledge graphs that people were building were starting to get too hairy, too complicated, too hard to maintain. They weren't adaptive enough for what people were trying to do. If this side of the world had actually been successful, then the heuristic side would actually have been quite successful. Unfortunately, because this side wasn't working, nobody wanted to spend the money. So the hardware market just collapsed overnight. DARPA withdrew its funding, and it sort of all came crashing down. So those are the rest of the graphs. which I did not show you in the earlier slides. All right, look how rapidly it falls. And this is 1 decade. This is 1 decade. So that's when the second AI winter begins, in 1980s. But, so, with that, I'm going to take a little bit of a detour. I'm going to talk about how the philosophy of epistemology and heuristics actually applies to the Lisp language itself. Okay? So, you can think of programs which are constructed, again, with nil quote cons, right? A Lisp program is just that. It is a knowledge graph in itself, right? It's a collection of data that you can manipulate. So your heuristics can actually manipulate your programs. Obviously, this gave rise to things like macros, which we all know and love. I hope there is no one here that does not love macros. Eval, compile, we saw a beautiful example with Colton yesterday where, the same philosophy that, I have my program graph, I can do things with it. And, we saw a great example of how that comes together. So, and I call this Lisp intelligence, right? It's the intelligence that embedded inside Lisp. It's the same philosophy. Symbolics, genera. Who here has heard these 2 words? Wow, good, like that. Symbolics, genera. If you've never had the pleasure of using a symbolics Lisp machine, I feel bad for you. It is available to use on Linux these days, so go ahead and try it. It will be worth your time. Symbolics, genera took this to another level. Okay, your whole system is the knowledge graph. And when I mean the whole system, I mean the whole system, right down to the objects in the operating system until you hit the hardware level. Every single thing was an object in your knowledge graph that you can grab a hold of, you can modify, you can put a generic function on it, you can make it behave differently, you do whatever you want it. Okay. It was a beautiful system. It's the best thing I've ever worked on, ever. Nothing since then has even come close. Okay? The heuristics on it was just unbelievable, right? The whole, you could get a REPL on anything, you could examine anything, you could get the documentation for it, you could look at the source code. One of the Redditors, whose name I forgot, unfortunately, to capture, said it beautifully. You can metadot all the way down to the hardware, right? Anyone here does not know what metadot means? Metadot is the Emacs command to go into the definition of something, okay? So metadot all the way down to the hardware. It's a beautiful thing to have, and I encourage you to go and play with Genera when you get a chance. But this theme here is important. I'll come back to it. Being able to metadot all the way down to the hardware is important in more ways than one. Okay. All right, coming back to our timeline. So it's 1985. Aristotle is giving away, the baton to Gauss here. So we're going from logic to statistics, which is sort of the story of modern AI. Okay, so let's look at another timeline here. Our focus again is 1985. So we're back, we were in 1955, we're back in 1985. Okay, so the world of statistics sort of begins with Blaise Pascal and Fermat and Gauss and Laplace and Bayes, all these people who did all the early work in probability theory and statistics. Their work, obviously lots of other people worked on it. Computing begins in 1940. Obviously people start trying to apply statistics and writing programs that are doing statistical calculations. Things like Bayesian inferencing, those things sort of start making it into expert systems, actually. So expert systems used to have some sort of Bayesian inference built into their heuristics, which was all great, right? Mid-1980s, Lisp is, the Lisp winter has begun, the AI winter has begun, but two big innovations start happening right around that time. Oh, I should point out one more thing. 1958, McCulloch and Pitts, they come up with neural networks. Okay, so in some ways, actually, neural networks and Lisp sort of invented about the same time, right? Lisp somehow, the Lisp and that sort of epistemology heuristics way of thinking about the world quickly got everybody's attention. It grew a lot. Neural networks, people were there. They were working on them slowly. And then it sort of all came together in 1986 when backpropagation got invented. And you could now start training bigger neural networks. Of course, at that point, the computing hardware wasn't really sufficient, so these neural networks were still small, especially by today's comparison. The other thing that got invented around the same time, convolutional neural networks. You may have heard this term. This is what enables a lot of the vision-based applications, so anything that deals with vision, images, video, they tend to rely a lot on CNNs. Another interesting development in the mid-80s is the availability of libraries, right? BLAS, anybody heard of BLAS? There you go. BLAS first came out, I think, 1979. Similarly, SAS, statistical libraries. So things are sort of starting to gather momentum until you get to the 1990s, where you now have LAPACK, which is, again, was built up on top of BLAS for linear algebra solvers. You start to get Python. Python was, I think, proposed in 1989 first. And obviously, people got excited about Python. And NumPy came out, SciPy came out in the 90s. These are all the numerical libraries that people were starting to use. The idea of support vector machines, which is machine learning but not deep learning, SVMs, hidden Markov models, all of those things came out in the 90s. And fast forward to 2007. Okay. Two major developments. CUDA comes out, right? So people started to realize, all right, GPUs can be used for more things than playing Doom. CUDA comes out, and Theano comes out. Theano was one of the first deep learning frameworks, again, in Python, but it started to use CUDA as well, right? So this is sort of the dawn of the modern deep learning revolution. The other big sort of milestone there is AlexNet. This was in 2012. AlexNet was the first neural net to win the ImageNet competition, which was a competition that they had for image analysis, image classification. And this was written entirely with deep learning. So it was a neural network winning the image classification contest. Okay. And that just changed the game. So 2012 was that's when I got interested in AI because everybody was talking about it. Okay. So that's how statistical intelligence came out. And you can look at it in slightly different terms, but in the same philosophy, which is what is the epistemology of statistical AI? Statistical AI is you're training these neural networks, you're building these complicated tensors or matrices effectively. You're doing these complicated neural network designs. So essentially, your knowledge is now encoded in these numbers. It's not a clean knowledge graph. You can't car and coder into it. there's no pieces you can grab and say, oh, this means that, I have to catch a train tomorrow. You can't pinpoint things over there. There's no cons. You can't cons on a new piece of knowledge onto your knowledge representation. You have to retrain your neural network. You have to do a gradient descent on it. It's a lot more complicated. Now, heuristics, for the same reason, now rely on inference and sampling. So you're looking at this probability distribution. You're saying, okay, does this value belong in this probability distribution? Or you're saying, can I generate a value that belongs to this probability distribution? So, you now need linear algebra libraries, you need GPUs, and you need a convenient language to do it all in, which in this case happens to be Python. But it's just for the bindings, really. Okay. So essentially, in statistical intelligence, the tooling is very complex. It's extremely complex. You need these high-performance libraries. You need, a very deep understanding of the mathematics. And really, it's sort of independent of language, People use Python because it was around, it was convenient, it was easy to use, it had all the bindings necessary. But Python itself doesn't run these things. These things are all run by these high-performance libraries. So the actual intelligence is somewhat independent of the language itself. Okay? But it's a different game, right? Epistemologically, it's a black box, right? You don't really know what's going on inside. The probability distribution is what it is. It's not explainable. This is what people will say, look, modern AI is not explainable. Some people will call it a statistical parrot. You may have heard those somewhat derogatory terms. A lot of the old AI practitioners don't like the fact that it's not explainable. You can't get your hands on the knowledge graph. So there's also the reasons why you get hallucinations, right? Your probability distribution is an approximation of your real world actual set of the actual probability distribution itself. So you get errors, you get hallucinations. And the heuristics only work by experimentation. So the only thing you can do with a black box, you can poke on it, you can beat on it and say, okay, what does it do when I give it this? And you get an answer back and you can do something with it. Right? So this gives rise to things like prompt engineering and agentic AI, and these are all the terms that you guys are hearing in the modern day. But it's really, it's like you're just throwing things against this black box and trying to figure out what's inside and how it works. Most importantly, there's no need for Lisp's epistemology. Right? You don't need to build a knowledge graph explicitly. So what happens is Lisp is just another candidate from a wide range of choices. Okay? Because all you're doing is trying to connect with these black boxes through whatever libraries, et cetera, APIs now. So that's where that leaves us. Okay, so this is the status of Lisp in this current sort of world of AI, that it's a language choice that we have. I'm sure everybody in this room would prefer to use Lisp, and versus any of the other names that are on the screen here, but the reality is that Lisp is nowhere. Okay. This is a chart of GitHub repositories that have been updated since 2024, 1st January 2024. And I've compared it with sort of two other contenders, Python and C and C++. And I've taken 3 sort of sample Lisps so we're 2 or 3 orders of magnitude behind in usage. Okay, I don't think we care about that. We use Lisp because we love it, and other people may not, but.
What's the difference between that one and that one?
Oh, sorry, yeah, good point. This is all repositories. This is only AI repositories. So, I should have clarified that. So, okay. On the other hand, Lisp is everywhere. The heuristics tools of Lisp inspire everything that's around us today, with the exception of C and C++. Java, invented by James Gosling and popularized by Guy Steele, two shining icons from the Lisp world. JavaScript, Brendan Eich actually wrote that as a scheme interpreter first, and as the story goes, the marketing people forced him to change the syntax to the ugliness that JavaScript is. Python, Guido van Rossum has said in many places, Lisp was one of his inspirations. Ruby, Lisp was one of its inspirations. Every other functional language that's out there traces its roots back to Lisp. And the methodology of Lisp, of interactive development, garbage collection, the ability to sort of have recursive data structures and do functional programming on these things. So in reality, Lisp is everywhere. What is missing is the knowledge graph and program equivalence. Right? None of these other languages actually treat their program as a knowledge graph. There are some lame attempts, I will say, but they're horrible to use. I don't know if any one of you has tried to write a Scala macro ever. So there are some lame attempts at it. But, this is what it is. Lisp is actually everywhere. In fact, Peter Norvig, one of the great names in artificial intelligence, says Python is an acceptable Lisp. And he came from the Lisp world. Now he almost exclusively uses Python, but he thinks of it as an acceptable Lisp. Okay, so on the one hand, Lisp is nowhere. On the other hand, Lisp is everywhere. It's just not the kind of Lisp that we like. So now we're in 2015 to 2025, and look at the next 30 years, 20 years from now. Lisp 2045. What role does Lisp have to play in the next 20 or so years? Okay. Now, if you believed my last slide, it's pretty much a candidate for doing development, but I have a slightly different point of view. Mostly because of the view of the future that I have. So everything that you saw until now is, how should I say? It's history. It's facts. It's my interpretation of the facts, but there's very little controversy in there. My next set of slides are much more controversial because I'm trying to predict the future, and I have certain opinions on it. Some of you are going to hate everything I say. Some of you are going to love everything I say. I hope there is no one in the middle saying, whatever place you land up, my hope is that I will make you think. All right? With that caveat, let me show you the scariest graph I have seen in a very long time, or in my entire career, I would say. Okay? This is hires per month by the top companies in Silicon Valley. US, you could say, mostly Silicon Valley. Since 2011, they hire roughly 1,000, 2,000, 3,000 people per month. It's a growing industry. Late 2022, ChatGPT comes out. Look at the steep fall. We first go negative. In early 2024, we're negative, okay? Which means we're actually net losing people in this business. And then it sort of slowly climbs up in 2025. We're now at 0, which means as an industry, software development has essentially stopped growing. Okay. Very small amount of data for 2025 to conclude what I'm saying, but there's also anecdotal things that people are saying. Facebook is saying 20 to 30% of my code is written by AI. Same thing, Microsoft is saying the same thing. Smaller companies are coming out and saying, we're not hiring any more software engineers. I expect you to use AI to do more work. So it's only one reaction that you can have to this, which is that. Okay? It's a scary, scary proposition that we're walking into. We're all software developers here. Right? This is the world we're walking into. The message is very clear. We don't need skilled coders anymore. Most of those 3,000 hires per month that have happened in the last 15, 16 years, they were filling very narrow slots in the development cycle, skilled coders, as we call them. Right? The message is that we don't need skilled coders anymore because I have Claude AI, I have Cursor, I have Replit, I have Bolt. If you've not heard these names, we'll have a discussion later on. But essentially, the idea is that AI is going to be writing a lot of the code. So then you might think, oh, great. All right, so I don't have a job in the traditional software development cycle. Maybe I train myself on AI tools, and then I'll go find AI companies and go work for them, right? Does not work. Future employers, okay? I put that in quotes because they're not employers. As of 2025, there are 12 billion-dollar unicorns, right? 12 unicorns, billion-dollar companies that have less than 50 employees. Think about that. Okay, you're valued at $1 billion and you have less than 50 employees. About half of them are not engineers, typically, as it happens. Right? So, if you look at Y Combinator, which is the startup incubator you guys might have heard of, not the Y Combinator that Lispers know. The startup incubator has now started asking for companies where you don't need a technology guy in your startup. They're expecting you to have figured out the business problem, and you know enough technology to sort of go to an AI and say, build me this app. And the AI builds you the app, and you go try it out in your market, and you do all of that. So new startups don't need as many developers as they used to. So future employers sort of don't exist. Or it's not that they don't exist, the employers are not employing software developers to the extent that we have been seeing in the industry so far. So we're now looking at a very different world. We're looking at a human and AI combination world in technology. AI does all the coding. Humans are telling it what to build, right? AI still doesn't know what to build. Humans are telling it what to build, and that'll probably be true for the next 20 years, till 2045, which is the extent of my prediction here. So what humans are doing, They're understanding, conceptualizing, designing, building, maintaining, evolving whole systems with very small teams and using lots of AI. Okay. So this is a very different world. You don't need skilled coders in this world. You don't need skilled coders. What you need are deep system visionaries. Technical people who understand the whole stack. You know, starting at the humanity of it. What do people need? What do people want? What is the emotional connection of people with my product or with whatever it is I'm building? How does that manifest into a UX and a UI? What are the algorithmics that I need in order to build my product? How do I put it all together? What are the libraries? What are low-level libraries, high-level libraries, language runtimes? If something breaks, I need to be able to go figure out what's broken, how do I fix it, whatever else, right? Even though I've not written the code, because the code has been generated by AI. So I still need to be able to do all that. I have to be able to metadot all the way down, because there's only 2 or 3 people who are running this whole big system. So you have to be able to metadot all the way down. You have to understand each layer of the system. Okay? So how does that tie to Lisp? I've given you a hint already. You want to be able to metadot all the way down. So how do we prepare this next generation of deep system visionaries? Okay. Now, this is my personal opinion. Teach everything in Lisp. Okay? Why Lisp? Okay. Let me take a slight detour here. If you look at the field of mathematics, lots of different subfields. You know, you have topology, you have linear algebra, you have all calculus, you have all of these things. They all share a notation. Right? They're all based on the same notation of either set theory or category theory, you know, however you want to think about it. In mathematics, you can always metadot all the way down to set theory, whatever your math is. You can metadot. Okay, this is the set theory that applies to whatever it is that I'm working with. Okay. There's only one equivalent in computer science that I know of that has the ability to meet the abstraction at the level you need to meet it at. And that's Lisp. It's the only notation that I know of that can work at every single level, from bottom to top, right? Otherwise, if you look at computer science today, it's a hodgepodge of notations. I got to know 100 different things before I, you know, even begin to understand a certain field, right? I have all this arcania, as I call it, all this arcania that you have to learn, and a small amount of, you know, things from first principles, and all this arcania in order to make it work. By teaching everything in Lisp, you can focus people on a common notation across any field in computer science. Focus them on first principles, on the basic principles of whatever field it is that they're looking at. You're not fighting notation, you're not fighting semantics. Everything is dealt with at the level it needs to be dealt with. So, you're essentially training this new generation of people on being able to metadot all the way down. Okay? And any academics in the room here? All right, so my appeal to you guys, go back and change your departments. Go back and tell your departments, look, what we're preparing our students for the future has completely changed. It really has. In the last 6 months, it has completely changed. If you don't change how you're training your people today, they're going to come out completely lost in this new world. Okay? So, with that, I will open it up to questions.
Thank you very much for this really enlightening talk. I'm sure we're going to have a lot of questions in the audience.
Thanks for the disturbing talk.
Thank you.
Would you mind going back to the slide where you have this drop in hiring of software
Sure.
engineers? So your claim is that this drops because of AI.
No, actually not.
However,
I will explain that.
Okay, but a lot of things happened in that time.
It did.
Right?
It did.
So COVID, Elon Musk bought Twitter and fired everyone, and so
Yeah.
justify again your claim in light of that, please.
So yeah, no, so that's a very good point. I should have mentioned that. So yeah, not all of this drop is because of ChatGPT. It's not. There was a lot of overhiring during the COVID years. Okay, but the COVID years are just that last 2020 to 2022 and a half. Right? It's not a whole lot. It doesn't correspond to that big drop. Okay, so you're right. So it's partially attributable to COVID hiring, but as you can see, that's not the whole truth. So.
Hi, so in one of the early slides you had something that said the first coming of AI. Was this a subtle hint at the second coming, and do you view AI as a future messiah?
No, I do not. I'm an avowed atheist.
Yeah, so thanks for this really inspiring talk. So I was wondering about this idea that you brought forward about teach everything in Lisp. So I really like this idea. And I was just wondering, how do you see this, how this would work in practice, basically? So would this be more about teaching the principles, like starting from first principles in the little learner, or what would be your thoughts
Yes,
on this?
I would start. I would start with things like that. Because, like I said, take any field in computer science. There's principles and there's arcana, right? And all the arcana is taken care of by AI now. The AI is going to generate all the code. So the only thing the human needs to know is, how does it actually work, right? What are the first principles of it, right? And I think once you start focusing your training, your pedagogy, you're producing people who understand that, okay, I understand the first principle, I understand the principles of this field, and I can have AI do all the work for me. That is the mindset that we need to have in people. And I think Lisp is a great way to do that.
Yeah, thanks.
Anurag, thank you for the presentation. I wanted also to address this point of teaching in Lisp. I think there's...
Can you speak up a little? I can't
yes.
hear you very
So
well.
there is, I think, a number of people here who have this experience of teaching, and especially trying to introduce Lisp in that process. And I also have this experience to some extent. And I would say that the main issue now, and it will go on for a long time, probably until maybe some drastic change in principles of teaching will be implemented, is that the principle of least common denominator. Yes, because now, if you come to a university and you start teaching, everyone expects, every student expects that, okay, Python is the lingua franca. So if you want to explain algorithms, if you want to explain some AI, if you want to explain anything, maybe not hardware, because Python doesn't go there, but if it were to go there, then it would. So they expect Python, and why? Because Python is simple, accessible, yeah, for everyone, not for the thinkers, but for these people who come there as they want to learn coding, this coders,
skilled coder.
skilled coders, yeah, and that's maybe the majority of the students, 95%, 90% of the students everywhere, I guess, maybe apart from some very top niche universities. I'm not sure, but I guess this is what's happening everywhere. And that's why universities, they cater to the students. They want to have mass, teach in mass, not teach the thinkers, but teach those coders. And so that's why the whole system is skewed towards this common Lisp, and that's why these things like Lisp and other brilliant ideas, they don't get the place they deserve in academia, although they could have it. So what's your take on this? How would you approach?
My take again on this is a little controversial. So I completely agree with you. Universities over the past 15, 20 years, they catered to the demand, okay, of the skilled coder, right? And fair enough, right? People coming into computer science, they were like, you know, I want to build a career in the industry. I need to have industry relevant skills. Industry is demanding industry relevant skills. Well, guess what? That's gone. The industry doesn't want skilled coders anymore. So universities are going to have to rethink their strategy of how to produce what the industry wants, which is these deep system visionaries. Right? You're not producing skilled coders anymore. So what does a deep system visionary look like? And that's my proposal for it. So.
The internet is quite busy discussing in meantime. Georgie maybe showed a tweet chat, and I have fished for one question over there. Related to the whole talk and the idea, won't this lead...
Can you please speak up? I can't hear you.
Yes, sorry. There is one question from the internet regarding the whole talk and the idea. Won't this lead to stagnation at our current technology level, if correct? Stagnation or even regression?
I don't think so. I don't think so. In fact, I think quite the opposite. Because now there is so much room for rapid redoing of things. You get an idea, you can get it implemented and tested, you know, in a coffee shop while you're buying a cappuccino, right? It's literally that quick. You're sort of iterating on ideas very, very quickly. So in fact, I think if anything, the pace of innovation is going to really increase. And again, if you're producing deep system visionaries, the deep system visionaries are going to be visionary. They're going to be imagining new things. They have to understand humanity. That's sort of very important. They have to sort of be able to relate their efforts back to what humans need. So I sort of feel like it'll be the opposite.
Okay. There is still time for many questions, so I'm going to go to the other side of the room very slowly so that I can shamelessly keep the mic for myself and ask 2 questions.
Okay.
First of all, I'm not sure I agree with the idea that we don't need skilled programmers anymore, in the sense that AI is hallucinating, as you mentioned, and will probably continue to do so. So maybe the programmers that we need are the ones which have a sufficient amount of skill to actually debug a hallucinated code generated
yes, to a
by
certain
AI.
extent. You know, I don't disagree with that entirely, but you know, say the AI has hallucinated something, and you're like, you know, you're sitting there looking at, let's say, for example, a gigantic matrix that has bad numbers. Now, if you didn't have the first principles of saying, how does this matrix actually work? You're not going to be able to do that. It is far more important for you to have the first principles, the principles of the discipline, to help you guide how you're going to debug. The language, you know, Arcania is easy to get. It's the other thing that's much harder to get.
Okay, and my second question was, when you say metadot all the way down, that sounds to me like talking about homogeneousness rather than heterogeneousness in a complete system. And so
yeah,
I'm wondering if Could this be, for instance, the rebirth of hardware and software co-design?
It is actually. I mean, if you looked at the most recent developments in FPGA acceleration of deep learning and other things, there are these systems that are coming up like Spatial and Clash, I think it's the other one's called, where you're actually developing software and hardware together in the same file, actually. And the compilers then go off and generate FPGA code to reprogram that. So absolutely, yeah. You want to be able to metadot all the way into the hardware.
Yeah, so I'm referring back to the GitHub statistics of projects. How many of those other languages have run their own GitHub, or their own GitLab, their own Git repositories? Because Common Lisp has its own GitLab.
Yeah, so no, this was only GitHub. The data I collected was only GitHub.
Common Lisp Common Lisp has been hosting code repository for more than 30 years. How many of the other languages have been hosting their own repositories continually?
I share that. I mean, obviously, that will change my numbers a little bit, but it's not going to change the order of magnitude.
Yet. Well, anyway, I think that one of the things for the Common Lisp GitLab is we should be mirroring everything at GitHub just for visibility for exactly these kind of things.
Sure.
So it's a good reminder and wake-up call.
Yes.
Thanks for that.
There's one from Hal, one from Luke first, and then Charles.
Okay, so my question is actually to everyone. There is one point of program I wanted to propose during today's hackathon, which is actually some kind of a workshop or a meeting teaching Lisp in 2025. And I wonder how many people would be interested in anything like that. Hands up, please, maybe. 1, 2, 3, 4. I guess it's enough, kinda. Okay, so I will talk with Didi and maybe add it to the program and find a spot for us. That's all from me, thank you.
Yeah, so I wonder if, as Lispers, we're heading into a little bit of an identity crisis here, where one of the defining social characteristics of Lisp is feeling very under-resourced compared with everything else. It used to be that we looked back at the 80s and the symbolics era, and they had all the resources, we don't have it now. Then we look at GitHub and we see all of the man-hours going to Python, and we don't have that, and we're all about doing more with less. But if we're coming into an era where we can just do those things ourselves when code is cheap, and we can spin up an AI and say, please port the Python ecosystem to Lisp, please fill out the blanks in my Genera, then how do we need to think coming into this era? How should we approach that?
So I actually, that's a great point. And one of the slides that I have, let me see if I can find it. Sorry, what am I doing here? Can you switch me back to my thing here? This is just a slide I cooked up, actually, just to put my thoughts together. What does language choice actually entail, right? This is sort of typically the order of priority today if you're going to select a language. And you look at the ecosystem, you look at the talent that's available, you look at the context in which you're working. So if you have to write a browser front end, JavaScript is really sort of the context that you want to work in. You look at the tooling, how easy is this to build and deploy with. Finally, you have designer bias, right? So that pretty much determines the choice of language that you have. With AI generating code for you, the ecosystem is largely irrelevant. Now, this is not, I say largely because there are big innovations, like you're not going to have AI generate a computer vision library for you. You are going to use OpenCV to do that. But you can have AI generate the bindings. Great, that's easy. So, so the ecosystem sort of is not as important anymore. Talent, not important anymore anyway. The context, maybe, now there's a website called codeconverter.ai that will generate any code from any code. So you want to write your front end in Lisp, and you want to have it generate, JavaScript, just write everything in Lisp, run it through this website, you have a JavaScript front end now, right? So, it's sort of your context is a lot more flexible now. Tooling is still a little bit important, but sometimes, very often you can build the tool you need. Not always, but you could do a lot of things with AI. So what remains? Just designer bias. Just use your bias, do whatever you want. So just use Lisp. And in fact, I had actually another thought. There's 100 or so of us at this conference. You could pretty much take your pet project every weekend between now and the next 12 months and produce 50 projects, put it up in the open source. Put it up on GitHub, put it up for people to use. Your favorite projects. Suddenly there's 5,000 new repos that have gone up and all working. And it's just a weekend's worth of work.
Okay, so I'm going to lead into my question with some similar controversial opinions. I want to see if it aligns with your vision a bit. So even with before AI, I always thought that, like, before this new wave of AI, I thought that, okay, so the profession of skilled coder is going to go away soon. Mm-hmm. Because just like the profession of being a scribe went away, I don't know, 1,000 years ago or something, because now every domain-specific profession, domain-specific knowledge-needing profession, like being a lawyer or whatever, everyone knows how to read and write. So being a scribe is no longer something we need.
Correct.
And we kind of see that similar trend now where, okay, you're a physicist, you're a linguist, you're a biologist, whatever. Everyone's learning how to be a skilled coder in addition to their domain-specific knowledge. So I always thought this profession of skilled coding would go away. Mm-hmm. And so, especially now that we have AI and everything, I was wondering what you think of, like, this idea of people not being programmers anymore, but people being something else. And programming is just something that is their existing domain-specific knowledge. So how does that fit into your vision of, okay, so we have AI in the future, the sort of domain-specific knowledge and kind of humanity being like, we're experts in other things, first principles in other domains. And programming is just being relegated to what writing was relegated to with respect
Correct.
to scribes. Like, how does AI play into that now?
Correct. So you're right about a lot of things. So as one of the things that I pointed out is Y Combinator is now looking for people who don't have to be coders. You're a lawyer, you have an idea, and you can generate an app with AI. Great, come, we'll fund you, right? So that's sort of starting to happen. However, to do anything at scale, right, you need to have the engineering chops to do it, right? And that's where the deep system visionaries are going to come in. So, sure, for writing a small app on the phone, yeah, you don't need a skilled coder anymore. But if you have to build, a system that scales to 1 billion users, 1 million of whom might be online at any time, has to work all the way across the world, 99.99% uptime, then you need to start. You really need to know how the stack works.
One final question here. Yes, thank you so much for a great presentation and the amazing journey you took us from the past to the future. I wanted to know your opinion because somehow it reminded me of an old lecture from a professor in the MIT. It's an old video, you can find it in YouTube on Introduction to Lisp. And he also takes people into an interesting journey into the past because he makes the analogy with the geometry. And then he says that the name comes from the old priesthood in Egypt when they were measuring the earth. And they thought they were measuring the earth for the floods of the Nile and to mark the fields again. But actually they were setting the basis for geometry, for formalizing, let's say, these notions about the space. Mm-hmm. And in the same way, he says, some people will look back to us in the future and think those ancient guys in the year 2000, they thought they were coding. But actually what they were doing was formalizing knowledge. Mm-hmm. And this comes with what you were saying, that the AI can do the coding for us, because our mission is going to be more about the definition of the things. And any of us who has worked with end users and how hard it is to have a clear definition of what they want, they actually know it after they've seen it, okay? And there is a lot of back and forth, what they really want, what they say, and what is really needed. But then in this paradigm that we only say and the AI is doing all the coding for us, there's going to be a lot of knowledge that somehow might be, let's say, the clarity, the transparency on this knowledge that is in this code might be a little bit lost by humans, unless the code is clear enough that is also human readable. I mean, another thing that the same person says always is write first code for humans to read and eventually for machines to prove. So what are your thoughts on this?
So at least the way the technology stands today, and I don't know how it will evolve in the future, the technology is very flexible. You can give it a lot of guidance on how you want it to generate the code for you. So I, in fact, have a file of racket rules that it needs to follow when it's generating racket code. So, and you can make this file, my file must be about, 100 lines or so, but you can make it 100 pages, and it'll follow every single instruction that you give it. So the technology is pretty flexible today. So you can get the code, yes, it hallucinates, yes, it makes mistakes, but it also fixes them. Sometimes it detects its own mistakes and fixes them. Sometimes you tell it, no, you made a mistake here, or it's like, oh, I'm sorry, let me redo that, and it'll redo it correctly. So there's, there's that. There's a Gen Z name for it. They call it vibe coding, which is just sort of, it is what it is. But I think it actually generates better code than most engineers I've worked with. So I think, that's sort of a little bit on us, on how we're going to use the technology.
Okay, let's please give a final round of applause to Anurag. Thank you so much for your talk.